Hello students, welcome to the class. So here we are going to start with the questions on amines and biomolecules. Today in this video we'll be doing the multiple choice questions on amines. Yes, organic compounds containing nitrogen. Not only we'll be discussing amines, but we'll be discussing in general all the organic compounds containing nitrogen. It might be amines, it might be what we say nitro compounds, nitroalkanes, it might be cyanides, it might be isocyanides. All of the questions we'll be discussing. In the next video we'll be taking up with the biomolecules. Okay, so let us start with the first question. The first question is triamino benzene is. So triamino benzene, so they have asked you benzene. So here let us see first, when they say it's benzene, it's nothing but benzene ring. Yes, so they have said a triamino benzene. That means NH2 group. There are 3 NH2 groups, and these NH2 groups I cannot write them anywhere. Yes, I have to represent them like this due to steric hindrance, you say. Yes, this is triamino benzene. So what is this triamino benzene? Is it a primary amine or a secondary amine or a quaternary amine or a tertiary amine? Always remember, when you have NH2 group, no matter where it is present, it is always a primary amine. Yes, amine. When you have NH group and a bond, it is always a secondary amine. When you have N tertiary nitrogen, it is always tertiary amine. And when you have this N and here there is a plus charge, it is quaternary ammonium salt. Quaternary ammonium salt. So do remember this. Looking where the NH2 group is present, you cannot say it is primary, secondary, tertiary. Unlike alcohols, if alcohol is present on primary carbon, we say it is primary alcohol. If it is present on secondary carbon, we say it is secondary alcohol. If it is present on tertiary carbon, we say it is tertiary alcohol, right? So unlike this, in case of amines, if NH2 group is there, it is primary amine. NH group, imine group is there, amino group is there, it is secondary amine. Tertiary nitrogen is there, it is tertiary amine. So this is primary. Yes. So what type of triamino benzene is what? It is primary amine. Next question. C3H9N represents what? C3H9N, it is nothing but amine. Let us see what all amines I can write. CH3, CH2, CH2, NH2. This is first amine. 1, 2, 3 carbon atoms. 4, 5, 6, 7, 8, 9 hydrogens and 1 nitrogen. Obviously, I can even write it like this: CH3, CH2, NH, CH3. Just see, 1, 2, 3 carbons, 3, 2, 5, 6, 3, 9 hydrogens and 1 nitrogen. Yes, I can even write it like this: 3 carbons, 9 hydrogens and 1 nitrogen. Yes, so it is what? It is primary, it is secondary, and it is also tertiary. So it is all of these. So as we have already discussed, amines are the functional isomers of each other. Primary, secondary, and tertiary amines are the functional isomers of each other, right? Okay. Moving to the next question. Select the quaternary ammonium compound from the given options. Quaternary ammonium compound. Trimethylamine. Yes, first is trimethylamine. Second is tribenzylamine. Third is dibenzylamine, and last is none of the above. See, there is a slight mistake in the question, in the options. The first option is trimethyl. It is not this. Please make a correction here. The first option is option A is trimethyl phenyl ammonium bromide. Second option is tribenzylamine. Third is dibenzylamine, and fourth one is none of the above. So which is the correct answer? Ammonium compound is quaternary, is nothing but which contains ammonium salt. So it is trimethylphenyl amine. I'll just show you the structure also. There is nitrogen, quaternary nitrogen here. Trimethyl, that means there are 3 CH3 groups and 1 phenyl, that is C6H5 group. plus charge, and then bromide, Br minus. So this is quaternary ammonium salt. So option A is the correct option. Okay. Tribenzylamine. No, that also doesn't come. Tribenzylamine, benzene group. Yes, dibenzylamine. No. So those are benzyl. Tribenzyl is, it is something like this: C6H5, N, C6H5, and here C6H5. So it is tertiary, right? Dibenzylamine, C6H5, NH, C6H5. It is secondary, right? So which is the correct option? Trimethyl phenyl ammonium bromide. Next question: which of the following is a tertiary amine? 1-methyl cyclohexylamine. So 1-methyl cyclohexylamine. Let us see. Cyclohexyl. That means there is hexane. Cyclo means it is a ring structure. 1-methyl. Let me say any of the carbon atoms becomes 1. I'll write it here. So it is 1-methyl. I need not represent CH3. It is understood. If this bond is there, it is CH3. Cyclohexylamine. That means NH2 group. Where NH2 group is there, that is number 1. Yes. And that at number 1 position, there is 1-methyl CH3 group. So this is the structure of the first option. Second option is triethylamine. Triethylamine. So triethyl, C2H5, N, C2H5, C2H5. Yes, so this is triethylamine. Tertiary butylamine. Tertiary butylamine. That means there is carbon, NH2, tertiary butyl. This is tertiary butyl group, right? So tertiary butylamine. And the last option is N-methyl aniline. N-methyl aniline. That means NHCH3. N-methyl aniline. So if you look here, what is this group? NH2 group. That means this is primary. NH, this is secondary. N, this is tertiary. NH2, this is primary. So the question is, which of the following is tertiary amine? Which one is tertiary amine? Triethyl amine is tertiary. So here you need to always remember what is being asked. See, primary, secondary, tertiary, NH2, NH, and N. If one of the hydrogen of NH3 is replaced by R, dash is obtained, and if 2 hydrogens atoms are replaced, then dash is obtained. Very simple question. If you replace 1 hydrogen of ammonia, you get primary amine, and if you replace 2 hydrogens of ammonia, you get secondary amine. So option A is correct, right? Next, what is the hybridization and geometry of amines? See, in amines, or amines are the derivatives of alkyl derivatives of ammonia. So nitrogen is sp3 hybridized, but as soon as we say sp3 hybridization, the geometry is not tetrahedral, because there are lone pairs on nitrogen. So there will be lone pair bond pair repulsion as well as bond pair repulsion. Therefore, though the hybridization of nitrogen is sp3, the geometry is pyramidal. The geometry is pyramidal. So the correct option is option D, sp3 hybridized and pyramidal geometry. Next, the correct IUPAC name for. What is the correct IUPAC name for the compound? Yes. So the compound is this CH2 double bond CH, CH2, and CH3. So whenever you are naming amines, we always take this as the whatever functional group is there, that is considered. And here there is methyl group. That becomes one side of the substituent, and this is another side. Another side has got 3 carbons, so I'll start numbering from here: 1, 2, and 3. So how do you write the name? This group is attached to nitrogen, this methyl group is attached to nitrogen. So this is 3 carbon atom. That means it starts with pro P, and this starts with M. So I'll write M first. So what is the name? N. This group is methyl. Then what is there? There is a 3 carbon atom chain. Therefore, it is prop. Yes, prop. And there is a double bond on second position. So prop 2-ene. And this is present, right? And we call it as 1-amine. 1-amine. So what is the correct answer? N-methyl prop 2-ene 1-amine. So this is the correct option. Okay. Then amino term is used when you have a common name. Identify the incorrect IUPAC name. Identify the incorrect IUPAC name. So you can see here CH3, CH2 twice, and CH3. So N-ethyl, N-methyl, ethanamine. Yes, that is correct. Yes, CH3, CH2, N, CH2, CH3, and here CH3. Yes, so how do we do the nomenclature? N-ethyl, E first comes first, then N-methyl, then CH3, CH2, ethane, amine. Yes, this is the correct name. Second one, CH3 three times attached to CH3 carbon, CH3, CH3, NH2. So what is the correct name? 1, 2, 3. 2 methyl, 3 carbon atoms, prop, single bond ane, 2 amine. Correct? So this is also correct. Then moving to the next one, CH3, NH, then CH. To this carbon, there is CH3, CH3 group. So numbering, how do I start the numbering? It is 1, 2, 3. I did not always, it should be first only. So I'll write as N-methyl. Yes, 3 carbon atoms, prop, single bonds, ane. And on second position, there is amine group. So propane 2 amine. Letter E will go. Propane 2 amine. That is also correct. Last option, CH3, C, H, CH3, and then we have NH2. So this is the compound 1, 2, 3. So the name is prop, single bonds, ane, 2 amine. Propane 2 amine, but they have given 2,2 dimethyl N propanamine. No, that is wrong. Yes. So the correct name is propane 2 amine. Simple name, but here they have given it wrong. So this is the incorrect nomenclature. So always do remember how to do the nomenclature. Yes. So some questions on nomenclature. IUPAC name of NH2, CH2, CH2N. Very simple. There are how many carbon atoms? There are 2 carbon atoms. So 1, 2, wherever you want to do the numbering. So it is ethane 1, 2 diamine. Ethane. Yes, letter E will be kept as it is because it is a consonant. So the correct option is ethane 1, 2 diamine. So this is the correct option. Yes, here you see there is a dash given and here there is a comma. No, that is wrong. So this is the correct option. Yes, ethylamine can be obtained by, yes, ethylamine they are saying. So ethylamine is C2H5NH2. Ethylamine, how do you obtain ethylamine? Action of NH3 on ethyl iodide, is it right? NH3 on ethyl iodide. Ethyl iodide. Yes, let us see. Ethyl iodide C2H5I plus NH3. What do we get? We get HI and then C2H5NH2. Yes, of course we get. Then action of NH3 on ethyl alcohol. C2H5OH plus NH3. What do we get? Here also we get H2O plus C2H5NH2. Yes. By both the reactions we get ethylamine. So correct option is option A and B. Both options A and B. Yes. So ethylamine can be prepared by action of NH3 on ethyl iodide as well as NH3 on ethyl alcohol. Reduction of nitroalkanes yields. Reduction of nitroalkanes yields. So you are going to carry out reduction of nitroalkane. Nitroalkane reduction gives us what? CH3, CH2, NO2. We have, let us say, when we carry out reduction, that means you are using some reducing agent, say SN bar HCl. 2 oxygens have to be removed in the form of water. So 2 water molecules come out. I need 4 hydrogens and here 2 hydrogens. So totally I need 6 hydrogens. We have as usual discussed it. I get CH3, CH2, NH2. Reduction of nitroalkanes always give amines. It gives amines. Yes. Next, which one of the following compounds gives secondary amine on reduction? Always remember, if you want secondary amine, nitromethane, just now we saw here, we always get primary amine. Yes, nitrobenzene, see, nitrobenzene, nitromethane they have said first. nitromethane, CH3NO2. When I carry out reduction, I get CH3NH2. So this is primary. Nitrobenzene. When I carry out reduction, I'll get aniline, which is primary. Yes. Then methyl isocyanide, CH3N triple bond C. When I carry out reduction, I'll get CH3NH CH3. This is secondary amine. Yes. One more example, methyl cyanide, CH3CN. When I carry out reduction, I'll get CH3CH2NH2. So out of all these, this, and this gives us primary amines. They give us primary amines. Only isocyanides give us secondary amines on reduction. On reduction, isocyanides give us secondary amines, whereas rest all give us primary amines. When ethanol is mixed with ammonia and passed over alumina, the compound formed is, see, what is the reaction when ethanol, C2H5OH, yes, it is mixed with ammonia, NH3, and passed over alumina, Al2O3. What do we get? Again, the reduction reaction, nucleophilic substitution, OH comes out, C2H5NH2. What do we get? H2O gets eliminated. So what do we get? C2H5NH2. We get amine, primary amine. Which of the following reactions will not give primary amine? So which reaction will not give primary amine? This is amide. Yes, amide CH3CONH2 Br2KOH. What do I get? I get CH3. This CO gets out and NH2. Hofmann's bromomide degradation, right? We'll get amine, primary amine with one carbon atom less. Second is CH3CN. Just now we have seen when I carry out reduction of cyanides, I'll get primary amine, CH2NH2. Third one, isocyanide, CH3NC, lithium aluminium hydride, that means reduction, CH3NH CH3. I'm getting secondary amine. So this is primary, this is primary, this is secondary. Last one is CH3CONH2 again. Lithium aluminium hydride. This will also give me CH3CH2NH2. See, these two reactions are different. Though you are using same amides only, Hofmann's bromide gives primary amine with one carbon atom less. Hamides, lithium aluminium hydride gives primary corresponding primary amine. So this is also primary, this is also primary, this is also primary, and this is secondary. So which one will not give primary? It is option 14. Yes. So you should be aware of all the reactions what we have discussed. Then it becomes easy. Yes. Okay. When methyl iodide is heated with ammonia, methyl iodide, CH3I, is heated with ammonia. Heated. They have said heated. So what do I get? Yes. CH3NH2 plus HI. Yes or no? I get a mixture of, what do I get? Methyl iodide is heated with ammonia. Okay. They have said heated with ammonia. So I can expect a CH3NH2. Again, further, if excess of ammonia is there, what will happen? CH3NH I'm sorry, not ammonia. It is CH3I. Okay. So I'll get this. Then further, CH3I, methyl iodide, CH3N, CH3, CH3. So I get primary, I get secondary, and even I get tertiary. So what do I get? A mixture of about 3 amines. Methylamine, yes. Dimethylamine, yes. Trimethylamine, yes. Yes, so I get mixture of all the three compounds. Which of the following gives primary amine in reduction? Okay, again, primary amine in reduction. NO2 is there. So here nitrogen is the attacking part. Therefore, what happens? These two oxygens go out and I'll get NH2 here. Correct? So I'll get primary amine here. Yes, I get primary amine here. What about this? This is nitrito group. Yes, NO2 is an ambident nucleophile. So it has two attacking centers. So this is nitrito group. I will not get secondary amine here, primary amine here, because here there is oxygen atom. Oxygen atom. Next, if you see NO3, nitrite, no. That we don't have reduction of nitrite to amines. No. So which is the correct option? It is option A. So here we get primary amine, correct? We get primary amine only in case of first option. Next question. A primary amine is formed from an amide on treatment with bromine and alkali. The primary amine has got a primary amine is formed from an amide by treatment with bromine and alkali. So the primary amine has whatever primary amine, when bromine and alkali is treated with amide. Yes, what happens? This is Hofmann's bromamide degradation. Yes, here you will get a amine, you will get a primary amine, with one carbon less, because carbonyl group comes out in the form of carbonate. So one carbon atom less than amide. Option A is correct. Next, the most convenient method to prepare an amine containing one carbon atom less. Which one it is? It is Hofmann's bromamide degradation. Just now we have seen. Yes, it will give one carbon atom less. In order to prepare primary amine from an alkyl halide with simultaneous addition of one CH2 group in the carbon chain, the reagent used as a source of nitrogen is. See, look at the question. You want to prepare primary amine from alkyl halide. That means I have alkyl halide. I am going to prepare primary amine with simultaneous addition of one CH2 group. That means whatever alkyl halide I am taking, I will get an amine with one carbon more. So addition of one CH2 they have said. Yes. So I should select with the source of nitrogen. So the source of nitrogen, can I say it like this? KCN. When I use KCN, I will get RCN. Cyanide I will get. This on further reduction. Do you remember this reduction? Mendes reduction. Yes, cyanides when treated with sodium in ethyl alcohol. What do I get? RCH2 NH2. So look here. One CH2 group is added in the chain and I have got primary amine. So what is the correct option? It is potassium cyanide. Potassium cyanide. What is the product formed in the given reaction? The product formed, the amides on reduction, this is reducing agent, will yield primary amine, CH2 NH2. Yes, so I get this compound. So you should be very perfect with the reduction reactions, all the reactions in fact. Next question. Reduction of CH3, CH2, NC. What it is? It is isocyanide, CH3, CH2, NC. In presence of, with hydrogen, in presence of nickel or platinum as catalyst gives. So write the compound. You get secondary amine. Yes, CH3, CH2, NH, and here we get CH3. So what do I get? I get secondary amine, which is the correct option. It is option B. Okay. Next question. Which of the following amides will give ethylamine on reaction with sodium hypobromide? Sodium hypobromide is nothing but NaOBr. Okay. This is not obtained directly. We need to take bromine plus NaOH. So which of the following amides will give ethylamine? So using this, you want ethylamine, C2H5NH2, bromine and NaOH. So you have to use bromine and NaOH or KOH, doesn't make any difference. So it is Hofmann's bromamide degradation. We know that in Hofmann's bromamide degradation, we will get one carbon atom less. One carbon less. So if I am having compound here with two carbons, then my reactant should have three carbons. And that reactant is nothing but amide. Amide with three carbon. Yes. So CH3, CH2, CO, NH2. Is this right? It is nothing but propanamide, correct? So it is propanamide. So you have to think the reaction vice versa also. What is the correct option? Okay, so it is propanamide. Next, ethylamine on heating with carbon disulfide in presence of HgCl2, ethylamine, C2H5, a reaction of amine, NH2, on heating with carbon disulfide in presence of HgCl2. So what do we get? We get C2H5 NCS. Yes, this is what we get, plus 2HCl plus HGS. So we get C2H5 NCS. So this is the correct option. Next question. Which of the following reacts with NaNO2 plus HCl to give phenol? See, NaNO2, sodium nitrite and HCl will react to form HNO2 during the reaction. Such reactions are called in situ reactions, right? So nitrous reactions we have seen, and it is giving us what? It is giving us phenol. So which one reacts with the nitrous acid to give phenol? That means I should have a benzene ring. Yes, so that compound will be benzene ring NH2. This will react with nitrous acid NaNO2 and HCl. It will first form diazonium salt. Yes, N2 plus Cl minus. This on further hydrolysis gives me what? It will give me phenol plus N2 plus HCl. We have seen this reaction. Yes. So if I want phenol, I am going to use aniline. I am going to use aniline. We have seen all the sets of reactions in this. Yes. Okay. Next question. When aniline is treated with sodium nitrite, when aniline is treated with sodium nitrite and hydrochloric acid at 0 degrees Celsius. Just now we have seen aniline. What is aniline? Primary aromatic amine is treated with sodium nitrite and HCl at 0 to 5 degrees Celsius. What do we get? We get further hydrolysis occurs. We get phenol, we get N2 gas. Yes, we get phenol and N2 gas. But here they have not mentioned further hydrolysis. So this is not mentioned. When this is not mentioned, this is not the product. So what do we get? What do we get here? It is not mentioned, so it cannot be the product. So hydrolysis is not said. So it will first give me what? It will first give me diazonium salt, which you can represent either like this, N2 plus Cl minus. So I get diazonium salt. Reaction of primary amines with aldehydes. Reaction of a primary amine with aldehyde. So primary amine, I'll take general reaction, NH2 with aldehyde. Yes. So aldehyde, can I write it like this? H and R. Yes. So reaction of primary amines with aldehydes. What is expected? We get R, CH2, N, H2O elimination occurs, and double bond CHR. Yes, it is nothing but aldimine. We get aldimine. These compounds are called aldimines. You can note down that reaction also. They are called aldimines. Next question. When primary amines are treated with HCl, when primary amines are treated with HCl, CH3, CH2, NH2 plus HCl, what is the compound obtained? We get CH3, CH. Amines are basic in nature, correct? And this is acid. So this explains the basic nature of amine. NH2, it will give its it will give its lone pair, and it will form NH3 plus and Cl minus. So it will form a salt. It will form a salt. What type of salt? It will form, see, name of the salt is ethyl, 2 carbon atoms, NH3 plus ammonium chloride. So it is an ammonium salt. It will form an ammonium salt. Which one of the following is the weakest base? Weakest base. So here we know that ammonia is given. So it is ammonia, then methylamine, then dimethylamine, CH3, trimethylamine, then CH3, NH2, methylamine. Let me write it like this. CH3, NH. So I write it like this. Is it right? So CH3, NH, CH3, CH3, NH2, then CH3, N, CH3, and here CH3. This is NH3. So which is the weakest base? Yes, if you see here, there is lone pairs are very easily available because of this structure. Methyl groups are very far from each other. So these lone pairs can be given very easily. So I can say this is most basic. This is most basic. Yes, compared to, so next, then we have primary amine, methyl group, positive inductive effect comes next. Then we have secondary amine, tertiary amine, due to steric hindrance, this becomes less basic. Ammonia, it is having all three hydrogens, so they want to contribute to this electrons, so it is least basic. It is least basic. So which is the weakest base? It is ammonia, which is the weakest base. We have discussed the basicity of amines. We have discussed the basicity of aromatic amines, even aliphatic amines also. Yes. Next question. Which one of the following factors affects the basic strength of amines? Which one of the factors affects the strength of amines? Solvation effect. Yes, when we dissolve it in water, the strength of the amines differs. Okay, fine. Then we have seen inductive effect. Yes, if the alkyl groups are there, they are electron releasing groups. They are electron releasing groups. Yes, so they will increase the basicity, and there will be difference in the basicity of the amines. Steric hindrance. Obviously, if the alkyl groups are very bulky, then steric factor also plays the role. So it is what all the options, they are the factors which affect the basic strength of the amines. Yes. Next. So all of these is the correct option. 30th question. Which of the following compounds react with NaNO2 and HCl at 0 to 4 degrees Celsius to give alcohol and phenol? See, always remember, aliphatic primary amines react with NaNO2 and HCl to yield alcohols. Aliphatic primary amines. Only those which are aliphatic primary amines, they will react. So first one is aromatic. Second one is aliphatic, and S, of course, it is primary. Third one is aliphatic, but it is secondary. And fourth one is neither aliphatic nor primary. So it is option B, which will react only with nitrous acid. Only with nitrous acid. Next question. Primary amines can be distinguished from secondary and tertiary amines by reacting with. So how do you distinguish primary from secondary and tertiary amines? Yes, primary amines, if you see, only primary amines react with chloroform and alcoholic KOH. Yes, to form isocyanides, while secondary and tertiary amines do not react. Primary amines will react with CHCl3 and alcoholic KOH to form isocyanates, whereas secondary and tertiary amines do not react with them. Yes, so if you see, oh, with methyl iodide, no, chloroform alone, no, zinc test, no. So it is option A. So you can distinguish primary and secondary, primary amines from secondary and tertiary amines. So only primary amines react with this. Secondary and tertiary amines do not react. Parachloroaniline. Parachloroaniline, NH2, correct? And anilinium hydrogen chloride produces chloride ion, which gives white precipitate, can be distinguished by, okay, parachloroaniline, anilinium hydrogen chloride, NH3Cl. This is anilinium hydrogen chloride. So anilinium hydrogen chloride, it is nothing but a salt, and here parachloroaniline is yes, it is just an organic compound. So if you see this anilinium hydrogen chloride, it produces chloride ion and gives white precipitate with the AgNO3. See, it is having chloride. This chlorine is not free due to resonance, but this chlorine is attached to the side chain. So when you treat it with sodium silver nitrate, it is a reagent to detect chloride ion. It will give white curdy precipitate. White curdy precipitate due to formation of AgCl. Yes, but here chloride ion cannot be set free. Yes, anilinium chloride is a part of aniline. Therefore, you can use AgNO3 to distinguish parachloroaniline and anilinium hydrogen chloride. Next question. Which of the following compounds cannot be identified by carbylamine test? Carbylamine test is only for primary amines. Secondary amines do not give carbylamine test. So out of this, which is primary? Option A has NH2 group, option B has NH2 group, option C has NH2 group. Therefore, they all are primary amines. That is, option D is having NH. That means it is a secondary amine and it cannot show carbylamine reaction. Next, allyl isocyanide. Allyl isocyanide. See, isocyanide means there is NC. Allyl group. Yes. So let us check. Allyl, how to explain allyl isocyanide? CH2 double bond CH, then we have CH2, and then we have N triple bond C. So at allyl position, there is a carbon double bonded to another carbon. So this is allyl isocyanide. So it is having what all bonds? So it is having 2 plus 1, 3, 4, 5, 6, 2, 3, 4, 5, 6, 7, 8, 9. It is having 9 sigma bonds. Sigma bonds, because double bond 1 sigma 1 pi, triple bond 1 sigma 2 pi. Correct? So here carbon hydrogen 2, this bond 1, here 1, here 1, here 2, here 1, here 1. 2, 3, 4, 5, 6, 7, 8, 9. Then how many pi bonds? 1, 2, 3. So there are 3 pi bonds. Then, yes, nitrogen, a lone pair. Nitrogen does not have, so there is here, correct? So 2 non-bonding electrons. 2, it is not on nitrogen. In isocyanides, it is on carbon. So it is 2 non-bonding electrons. Or you can say 1 lone pair of electrons on carbon. On carbon. So what is the correct option? 9 sigma bonds, 3 pi bonds. Yes, this is the correct option. So remember, the question here is to make you understand, in isocyanides, nitrogen is not having lone pairs. It is the free electrons present on carbon. Casein reacts readily to give cyanide with, yes, it is, if you want cyanide, so you have to take what? Alkyl halide. Yes, so C2H5 Cl, let me say, plus KCN. So what do I get? C2H5CN. So I get cyanide. So it should be treated with ethyl bromide. Ethyl bromide. The alkyl cyanides, when hydrolyzed to corresponding acid, the gas evolved is alkyl cyanide. So alkyl group cyanide hydrolyzed. So hydrolyzed. Yes. So what do we get? We get corresponding acid COOH. So 2 here. What is the gas liberated? The gas liberated is ammonia. The gas liberated is ammonia. When you get acid, what is the gas liberated? It is ammonia. Okay. Next question. Which one of the following will give primary amine on hydrolysis? Nitroparaffin. No, it will not give primary amine. Yes, paraffin is something which is not related to this topic. Alkyl cyanide. Alkyl cyanide. RCN. It will give primary amine, right? It will give primary amine. Oxime. Oxime all will not give primary amine. Which one of the following? The question is, which one of the following it is which will not give? Because nitroparaffin will give primary amine, alkyl cyanide will give primary amine, oxime also will give a primary amine, but isocyanide will give secondary amine. So there is a mistake in typing. So which one of the following will not give primary amine on hydrolysis? So it is option D. This will not give primary amine because it will give a secondary amine. Reduction of methyl isocyanide, CH3NC. Methyl isocyanide on reduction, lithium aluminum hydride. So what do I get? CH3 NHCH3 dimethyl amine. I get dimethyl amine. That is an example for secondary amine. So reduction of cyanide gives primary amine, whereas reduction of isocyanide gives secondary amine. Next question. Which of the following reacts with chloroform and a base to form phenyl isocyanide? See, there is a chloroform CHCl3 plus there is a base, let me say KOH. It is going to form phenyl isocyanide. So it is going to form phenyl isocyanide. So if you want phenyl isocyanide, I should take aromatic aniline, sorry, aromatic compound. Yes, I have to take here aromatic compound, and that aromatic compound is nothing but aniline. So aniline, when treated with CHCl3 and KOH, I get isocyanide, phenyl isocyanide plus KCl plus H2O, right? So thus, in this reaction, phenyl isocyanide is produced. What is this reaction also called? Carbylamine reaction. Isocyanates are called carbylamines, having foul smell, bad smell. Yes, it is called carbylamine reaction. Next question. The color of p-amino azobenzene. It is one of the product, or you can say a dye obtained by coupling reaction between diazonium salt and aniline, correct? So this is nothing but para-amino azobenzene. Yes. So the color of this salt, dye is orange color. The color of this dye is orange color. Coupling reaction. Yes, a typical reaction of organic compounds containing nitrogen, wherein the carbon-nitrogen bond does not get broken. Yes. Next question. Coupling of diazo salt with phenol. Yes, coupling of diazo salt. So there is a diazo salt, N2 plus Cl minus. Coupling of a diazo salt with phenol. Always the coupling reaction occurs at para position of the OH group. So what do we get? We get benzene ring. Coupling reaction. The nitrogen bond remains intact. Attack occurs at para position. And here you have OH. So we get what? We get phenoxide is formed, which is more reactive. So phenoxide ion is formed, O minus, which is more reactive. So option, it is basic solution. We get a basic solution. Yes. Next, benzene diazonium chloride is the name of benzene C6H5 diazonium N2 plus chloride is a name of. Yes, this is the compound. Diazonium salts, we have seen the nomenclatures, as well as we have seen the methods of preparations also. Yes. Next, diazonium salts. Diazonium salts also form complexes with metallic salts such as zinc chloride. What is the correct structure of the complex? See, diazonium salts, they also form diazonium salts also form complexes with metallic salts such as zinc chlorides. And here the correct structure is, we have benzene ring N2 plus, this is N2 plus, with zinc chloride ZnCl4 minus 2. Yes, N2 plus it is, therefore here it is minus 2. So this is the correct structure. Ar N2 plus, and here I have two molecules, ZnCl4, because Cl4 is there, and minus 2. So this is the correct option. Diazonium salts, they form complexes with metallic salts. Okay. Next, the diazotization of two feebly basic aromatic amines is achieved by using, diazotization of aromatic amines is achieved by using nitrous acid. Diazotization, nitrous acid. If you have nitrous acid, then only diazotization reaction occurs, and this nitrous acid being very unstable, instead we use here NaNO2 plus HCl mixture, which will react during the reaction to form our nitrous acid. Yes, and such reactions are called in situ reactions, reactions where highly unstable compounds are prepared during the course of reaction using different reagents. Such reactions are called in situ reactions. Yes, in situ reactions. The coupling reaction of aryl diazonium chloride with aniline is carried out in. It is carried out, see, remember this, aryl diazonium chloride with aniline. Aryl diazonium chloride is basic, aniline is also base. Therefore, this reaction is carried out in mild basic medium. So option C is correct. It is carried out in mild basic medium. Next question. Diazonium salts are intermediates in the preparation of variety of aromatic compounds using. They are formed as intermediates. That means during the course of reaction, they are not the final products. You cannot extract them out, right? So they are formed as intermediates in a preparation of variety of compounds, including dyes, So correct option is including dyes. Next question. The amines are basic in nature. The amines are basic in nature. Hence, they form salts with hydrochloric acid. Yes, they form salts with hydrochloric acid. Which of the following will be insoluble in dilute HCl? Which of the following? There is no free hydrogen. If there is free hydrogen, it will be soluble. So where there is no free hydrogen, there they do not form salts and they are not soluble in acids. So if you see here, is there free hydrogen? Yes, NH2 hydrogen is free. Yes, look at option NH2, NH, NH. So here this is primary amine, this is primary amine, this is secondary amine. There are free hydrogens. Can you see this? So these are free hydrogens. Yes, therefore they will be soluble. But if you look at this option, tertiary amines do not have free hydrogens. They do not have free hydrogens. Hydrogens attached to nitrogen. So it is C6H5, N, C6H5, and here C6H5. So nitrogen is not having any hydrogen to get out. So these tertiary amines, they do not have free hydrogens, hence they do not form salts and they are not soluble in acids. So it is option B. Identify X, Y, and Z in the reaction. So reaction starts with an alkene. So CH2 double bond CH2. You are treating it with bromine in carbon tetrachloride. So what do you get? A double bond gets broken. Yes. Test for unsaturation. Br attacks at both the carbon atoms. So we get ethane 1,2, sorry, 1,2 dibromoethane. Then they have said it is treated with NaCN. So this is product X. When you treat it with NaCN, Br atom gets substituted with Cn. So what do you get? Here we get Cn and then CH2. Here we get Cn. So this is product Y. Then further lithium aluminium hydride. Lithium aluminium hydride. So what do we get here? CH2, then CH2, NH2, and then CH2. This carbon becomes CH2 and then NH2. So this is product Z. So X is CH2Br, CH2Br, correct? Y is Cn. Where is the product? Okay, this is Y. CH2, Cn. Yes. And what is Z? Is it correct? Z is yes. So option D is correct. So clearly we should understand the reactions. So option D is the correct option. Which of the following reagents would not be good choice for reducing an aryl nitro compound to an amine? So aryl nitro compound to an amine. Yes. If you look at these reagents, aryl nitro compound. So aryl nitro compound to an amine. So it is aryl nitro compound to an amine. So they have said which is not good. H2 excess platinum. Yes, of course, I'll get the reaction. Lithium in ether. If you take lithium in ether, it reduces aryl nitro compound to azo compounds. I'll tell you. If you take lithium aluminium hydride in ether, very typical. Yes. What happens is you will get N double bond N again C6H5. So you will get azo compounds. You will get azo compound if you take lithium aluminium hydride. Iron in HCl, yes, you will get NH2 SnHCl. So here we will not get amine. So this is the correct option. Which of the following methods of preparation of amines will not give same number of carbon atoms? Same number of carbon atoms. Reaction of nitrite with lithium aluminium hydride. Yes, we will get it. Then reaction of amide with lithium aluminium hydride. Yes, we'll get it. Heating of alkyl halide with potassium salt of phthalimide. Gabriel phthalimide synthesis will get the same number. Treatment of amide with bromine. This is Hofmann's bromamide degradation. And we will not get same number of carbon. Here we'll get one carbon less. So this is the correct option. So you should identify what are the reactions. Then you can say what is the product. Yes, all other reactions, if you see, they give same number of carbon atoms in the chain of amines as in the reactants. But it is option D, which is Hofmann's bromamide degradation. It will give one carbon less. Which of the following amines will give carbyl-amine reaction? As we have discussed, only primary amines will give carbyl-amine reaction. Secondary and tertiary amines will not give. So carbyl-amine reaction is a test to distinguish primary amines from secondary and tertiary amines. Yes, only primary amines give this. So which is primary? This is tertiary. This is secondary. Primary, secondary. So this will only give carbyl-amine reaction. Next question. Acetylation of secondary amine in alkaline medium. Secondary amine, it is R, NH, R dash. R and R dash may be same or different. Acetylation. Acetylation means I'm going to take acid chloride. Yes. What do I get? Yes, what do I get? So I get acetyl group gets added. So here I get R, NH, CO, CH3. So this R dash goes out with H. So R, HCl comes out and this gets substituted here. So I get R, NH, CO, CH3. So what is the name of this compound? It is, okay, hydrogen gets substituted. I'm sorry. So here I get R. So N, N dialkyl acetamide. So N, N dialkyl acetamide is the correct option. R does not get substituted. Hydrogen gets substituted. Hydrogen goes out. In place of hydrogen, we get a C double bond O CH3 group added. Yes. So N, N dialkyl acetyl chloride is the correct option. Next question. Aniline can be converted into benzyl amine. Aniline. Aniline you have. This can be converted into benzylamine. Benzylamine is benzene ring CH2 NH2. This is benzylamine. Okay. Which of the following processes of sequences? Let us start with the first one. NaNO2 and HCl is nothing but nitrous acid. With nitrous acid, we know we get benzene diazonium chloride. N2 plus Cl minus. Then, Cl minus. Then it is treated with CuCN. Okay. With CuCN, Sandmeyer's reaction type, we get Cn here. N2 comes out and CuCl comes out. Okay. Then further they have said H2 in presence of nickel. Cyanide with this, we get CH2, NH2. Yes, here itself we get benzylamine. So this is the correct option. Second option, aniline is there, bromine carbon tetrachloride. We will get no, we will not get the reaction here. Third option, K2Cr2, no, we don't get. Fourth option. So option A is the right option. Let us not waste time in looking at the others. Name the product. You can check out the other reactions also, sequences of the reactions. Name the product formed during the reaction of primary aliphatic amines. Very, very interesting question. Primary aliphatic amine with nitrous acid. With nitrous acid. What is the product formed? Primary aliphatic amines react with nitrous acid to form aliphatic diazonium salt. Yes, aliphatic diazonium salt. Let me say CH3, CH2, N2 plus Cl minus. It is very unstable. It is very unstable. It will undergo hydrolysis. It will undergo hydrolysis and form CH3, CH2, OH. And N2 comes out. And HCl. So remember, primary aliphatic amines. Primary aliphatic amines, when treated with nitrous acid, form alcohols. Corresponding alcohols. Whereas primary aromatic amines, when treated with nitrous acid, they form benzene diazonium salts. And benzene diazonium salts are stable. They are stable. Next question. The reaction of diazonium salts can be divided into two categories based on, see, The reaction of diazonium salts can be categorized into two categories based on the reactions involving displacement of hydrogen. Yes, hydrogen comes out in some of the reactions and the hydrogen remains in some of the reactions. I will show you an example also. You have studied about Sandmeyer's reaction. What happens in Sandmeyer's reaction? N2 plus Cl minus. In Sandmeyer's reaction, when you use CuCl and HCl, you will get chlorobenzene plus N2 plus HCl, correct? And if you take a benzene diazonium chloride N2 plus Cl minus and treat it with phenol, at para position the reaction occurs and we get, you can see here, N, double bond N, we get a diazo compound which is also called as a di, correct? So if you look at these two different, there are many reactions here in this case, the first case, okay? If you look at these two reactions here, carbon nitrogen bond has broken down. There is a fission of carbon nitrogen bond, cleavage of carbon nitrogen bonds, only nitrogen gas has evolved. But if you look at this reaction, the carbon nitrogen bond has remained intact. These are substitution reactions. This is coupling reaction. Yes. So in both the cases, so these are the two categories for diazonium salts. So it is A also and it is B also. So it is option C, both A and B. Identify the correct pathway to convert propanoic acid to ethyl amine. So propanoic acid we have CH3, CH2, COOH. Yes. So what you need to do, you want to convert it to ethylamine. That means there should be one carbon less. So I have something here, ethylamine. Here I should get amide, right? If I get amide here, I can carry out what you say, Hofmann's bromide degradation. So this is available and this is also there. Okay, okay. So both are there. I cannot go for these two. So when I take Hofmann's bromide, why I said Hofmann's bromide degradation? Because if you take Hofmann's bromide degradation, you will get one carbon less. Otherwise, no, you will get corresponding. So it is either option B or option D. So if you take SOCl2, what happens? OH group gets converted to chlorine. And here if you take HCN, nothing will happen. So let us see this reaction only first. So SOCl2, CH3, CH2, COCl. Okay, we get acid chloride. So this is reagent A and this is product X. Then if you take B, what is it? It is NH3. Yes, ammonia. What happens? There is elimination of HCl. This is reagent B, what I've taken. I'll get CH3, CH2, CO, NH2. Yes, of course. And this on treatment with Br and KOH, I get CH3, CH2, NH2. So this is the correct pathway. Option B is the correct pathway. If you can look at for option D also, you will not get it. HCN does not reduce it. It will not reduce it. Yes. So that is the correct option. Next question. Which of the following is the weakest Bronsted base? Bronsted base, where it will give an H an H plus gate, where it gives H plus easily, takes H plus easily. That is Bronsted base. But they have said weakest, which will take too much time to take H plus. Because if you look at aniline, nitrogen is having lone pair. Here, in all the cases, there is lone pair on nitrogen. But if you look at aniline, I can say aniline is the weakest Bronsted base because there will be delocalization. Since it is benzene, there will be delocalization of pi electrons. So when there occurs delocalization of pi electrons of nitrogen atom into the benzene ring, so electrons go into benzene ring. It will not go to hydrogen. Therefore, this becomes the weakest Bronsted base. Next, which would you be the side product? Which would be the side products formed with the primary amine in Hofmann's bromomide degradation? CH3, CONH2, bromine plus KOH. What do I get? I get one carbon less amine, CH3NH2, plus I get KBr, plus I get H2O, correct? KBr and H2O. Okay, if they have mentioned NaOH, I'll get NaBr and H2O. Okay, it is Hofmann's bromide degradation, NaBr, H2O, and carbon comes out as carbonate, Na2CO3. Yes. So balance the reaction. NaBr, Na2CO3. So I cannot make it 3 here. So 2 plus 2, 4. So here they have taken NaOH. So here 2 plus 2, 4. So I'll take 4 NaOH. Then 2 NaBr, H2O, Na2CO3. Correct? So 4 NaOH, that means here it is 2 H2O. So here, what are the side products? NaBr, H2O, and Na2CO3. So it is option C. So Hofmann's bromide degradation, even in most of the reactions, you should be knowing the side products also. Which of the following? Okay. Electrophilic substitution of bromine, aniline with bromine water. Aniline, we have discussed this. NH2. Bromine water is being used. Yes, you are not using any reagent here. You are just using bromine water. If you would have used carbon disulfide or carbon tetrachloride, you would get ortho and para product. But since here bromine water is used, all the ortho and para positions get substituted by bromine, bromide ion, and I get 2,4,6 tribromoaniline. I get 2,4,6 tribromoaniline. Yes. Next, the Heinsberg reage test of a compound C5H14N2 produces solid salt that is insoluble in 10% NaOH. This solid derivative dissolves in 10% aqueous sulfuric acid. Which of the following would be best describe these facts? See, tertiary amines do not react with Heinsberg's reagent. Heinsberg's reagent, no reaction. Yes. Secondary amines react with Heinsberg's reagent, but it is not soluble in alkali. Whatever white product is formed, white PPT, it is insoluble in alkali, in base. And primary amines, it will react with Heinsberg's reagent. It will form white product, which is soluble in alkali. So what is the correct option? So here they have said it is compound this. It produces solid that is insoluble in 10% NaOH. So it should be, it produces white solid. So when it is producing white solid, it should be a secondary amine or a primary amine. So here if you see, this is primary amine, but this solid derivative dissolves in 10% aqueous sulfuric acid. That means there is a tertiary nitrogen group. Therefore, it is option B. It is option B. So tertiary amines do not react with Heinsberg's reagent. Secondary amines react but is not soluble in alkali. It is not soluble in alkali. So that is the correct option. Secondary amines can be prepared by. Secondary amines can be prepared by. So you want to prepare secondary amines? It can be prepared by. Is it by reduction of nitro compounds? If you take a reduction of nitro compound, what happens? You get RNH2, correct? Then reduction of amides, RCONH2. What do you get? You get RCH2NH2. No, you get primary amine. Reduction of isonitriles, RNC. What do you get? RNHCH3. This is primary. This is primary. This is secondary. Last option, reduction of nitriles, RCN. I get RCH2NH2. I get primary. So only in case of reduction of isonitriles, I get secondary amines. Yes. Next question. The correct decreasing order of basic strength of the following species: water, ammonia, OH minus, and NH2 minus. Ammonia is, see here, ammonia is more basic than water. It is more basic than water. Therefore, NH2 minus is what? NH2 minus is nothing but it is conjugate. It is conjugate base of weak acid. Weak acid, that is ammonia. Yes, you remove one hydrogen, it becomes NH2 minus, correct or no? So it is a stronger base than OH minus. So NH2 minus is stronger base than OH minus. So what is the correct order? NH2 minus, then comes OH minus, and then comes NH3, and then comes H2O. Yes, so this is the correct order. So NH2 minus OH minus NH3 and H2O. So here you need to understand conjugate base and conjugate acid pairs, how to write it. Yes. Next, the structure of product X in the following reaction. So what is the reactant used? There is methyl group over here, CH3. Here there is NO2. Here there is NH2. Okay, so NH2 is there. Fine. When you treat it with NaNO2 and HCl at 0 to 5 degrees Celsius, what happens? All the parts remain as it is. CH3 remains as it is. NO2 remains as it is, but NH2 gets converted to N2 plus Cl minus. It will form benzene diazonium salt. This, when treated with H3PO2 and water, what happens? This part goes out. This is a reaction where benzene is prepared, we say, correct? So these parts remain as it is. Hydrogen comes there. Here hydrogen comes. So this is what we get. This is the product what we get. So what is the correct option? It is option A. A compound with molecular mass 180 is acylated with CH3COCl to get a compound with molecular mass 390. So the number of amino groups present per molecule of the former compound is. See, by the reaction of 1 mole of CH3COCl, so it is acylated with CH3COCl, that's it. If you take this, it is nothing, it is 1 mole, correct? 1 mole of CH3Cl with one NH2 group. With one NH2 group. The molecular mass increases with 42. See, total, if you see, it will increase with 42. It will increase by 42. Since the mass increases by 390, so it is 180, it is increasing by 390. So let me minus it and see. 390 minus 180 is how much? It is 210. It is 210. So 210, it is having one NH2 group. So what is the correct option they have asked? So the correct option would be acylated. So to get a compound with molecular mass 390, number of amino groups present. So just imagine there is a compound with 210. So what happens here? If I take an amine plus CH3COCl, what do I get? R NH C double bond O CH3. So how many amino groups? That will be how many the number of NH2 groups increase how much? Observe here. So it will be, correct option is 42. 42, it increased by 42 units. So here it is 210. How many times? How many times? It is 5 times. So number of amino groups will be 5. Number of amino groups will be 5 because HCl is coming out here. So check out here. So it is 210, 390 minus 180. So 210 means how many amino groups can fit into it? So it is option 5. Yes, option 5 is the correct option. Next, on heating aliphatic primary amine with chloroform and ethanolic potassium hydroxide, the organic compound formed is aliphatic primary amine. So R NH2 with chloroform and alcoholic KOH. What is the compound formed? The compound formed will be RNC. Yes, plus KCl plus H2O. Isocyanide is formed. Or amine. So it is alkyl isocyanide. Considering the basic strength of amines in aqueous solution, which one has the smallest pKb value? Aliphatic amines are more basic than aromatic amines. Okay, so if you consider all of them, I can write it like this: CH3 twice NH, CH3 NH2, and then CH3 thrice N. Okay, among aliphatic amines in water. Okay, among C6H5NH2 and then CH3NH2, then CH3 twice NH2 and CH3 thrice NH2, C6H5NH2 is least basic because there is resonance. Because of resonance effect, it is least basic because electrons of nitrogen are contributed in resonance. So it is least basic. Out of these three, out of 1, 2, 3, yes, CH3 twice NH is most basic because of positive inductive effect. Yes, and hydrogen bonding in water. So which is the correct option? So which one has smallest, which is most basic, that will have smallest pKb value. So it is option C. In water, it differs. Solvation effect, steric hindrance, everything comes. In water, they have asked that aqueous solution means in water. So it is option C. In the reaction, NH2, CH3, NaNO2 and HCl, that is nitrous acid. So what is the product you get here? You get diazonium salt, and here there is methyl group. So I'll write En2 plus Cl minus, and then with CuCnKCn, CuCnKCn, this remains as it is. Here it becomes a Cn plus N2 comes out. So what is the product? This is the product. In the Hofmann's bromide degradation, the number of moles of NaOH and Br used per mole of amine. How many moles of NaOH and Br used? So let us write the reaction and see. So here R, C double bond O, NH2 plus Br2 plus KOH, we use alcoholic, gives R NH2, one carbon less, plus NaOH they have said, okay. They have mentioned NaOH, so we'll write NaOH only. So what they have mentioned, we'll take that, NaOH. So here I get NaBr plus Na2CO3 plus H2O. So bromine, there are 2, so I'll balance writing 2 here. So 2 plus 2, 4. So 4 I'll write here. 4 NaOH means there will be 4 water molecules. So what is the question? Number of moles of NaOH and Br2 used. So 1 mole of Br2 and 4 moles of NaOH. 4 moles of NaOH and 1 mole of bromine. So you should be knowing the byproducts, and you should be knowing always to balance the reaction. Next, which of the following compounds will form significant amount of meta product during mononitration? During mononitration, which of the following will form meta product, significant amount of meta products? Here, aniline, when you carry out nitration of aniline in presence of HNO3 concentrated H2SO4, what happens? We get NH3 plus ion. This will abstract NO2 plus, yes. So we will get benzene ring NH2 at ortho position NO2. We will get benzene ring NH2 at meta position NO2. We will get benzene ring NH2 at para position NO2. We know this reaction. Para position, the yield is 51%, least steric hindrance. You expect aniline being electron releasing group, we expect ortho and para, but we get meta product also. Ortho product is only 2% and remaining is meta product. Yes, so we'll form significant amount of meta product during mononitration. So which one will form? It is aniline. Aniline will form. If you take NHCOCH3, you will get only ortho and para products separately. Yes, phenol, you will get ortho and para product. There is no doubt in that. Ortho para substituted products. This also gives us ortho para substituted. Yes, but here it gives us meta product also. We get all three. Ortho is least, most steric hindrance. Para is highest. Yes, the next question. So option D is the correct option. The increasing order of basicity of the following compounds. Increasing order of basicity. If you look at option A, This is what? Amidines. Yes, amino group, and there is a double bond. Okay. Okay. So these are some of the options which are being given. So which is the correct option? Increasing order of basicity that is being asked. Increasing order of basicity. If you look at this compound, so the compound is nothing but amidamine. These are strongest bases. These are called amidines. So these are strongest organic bases. So C option is first, strongest. Yes. Then comes what? So this is strongest means they have shown a lesser. So this comes last. Okay. Then look at the other options. There is NH and there is a double bond. Here high electrons are taken by this. So it will not, nitrogen will not give its electrons. So it's least basic. So B comes first. Here there are two options, but C being the most basic, this is the correct option. So option A is the correct option. Yes. So these are some of the questions what we have discussed today. In the next class, we'll be discussing remaining questions of amines and biomolecules. Thank you. Have a nice day.